Hey gamers and game devs, in this video I'm taking on the challenge of making a snake game clone with a twist, using just one script and aiming for under 100 lines of code. This idea came from a YouTube poll I made on my channel, and I was determined to pull it off. For those of you that may not know the snake game, it was a mobile game made popular on Nokia phones back in the late 90s. You took control of a snake that you moved around the screen using the arrow keys to collide with dots that were randomly placed on the screen. Every time the snake collided with a dot, the snake got longer. If the snake collided with its own body, it was game over, and the goal was to grow the snake as long as you could. I took this formula and added my own spin to it. I made grow food to grow the snake and shrink food to shrink the snake. I also made it so that if the snake collided with the grow food, it would leave behind waste that if the head of the snake collided with would trigger a game over. And also leaving the play area or colliding with its own body would result in a game over too. Now spoiler alert, I kinda came close to the 100 lines with the base game, but with the twist and some extra features I went a bit over. Still, I think the result is a compact, fun, and I would like to think a clean implementation of Snake in Godot 4.3. Let's get started. You may be asking, why one script for beginners? This simplified structure makes it easier for beginners to think about and understand the code by keeping all the logic in one place. It also makes it easier for debugging because all the code is in one place. So errors and bugs are easier to find and get fixed. It also reinforces understanding the fundamentals of the basic concepts without complexity. In the snake game, we will be discussing core concepts like collision detection, input handling, spawning in objects, and scoring. And because of its quick feedback loop, it will be easy to playtest and refine. We will also take a look at some simple UI elements, and as a bonus, I will even throw in a really cool way that you can implement some shader code. This shader code will be on a separate script because we won't be writing the code. We'll just be copying and pasting it from godotshaders.com and making one slight adjustment. But more on that later. I've decided to discuss the various aspects of the scene tree, the systems being used, and the code as they appear in the game. That way, I think it would be easier to follow along, because we'll be discussing things as they happen in the game in real time. We may have to skip ahead and come back to some things later on as needed to keep focus on one specific idea at a time. So it's not going to be a step-by-step video, but instead it's more of a, this is how I did it, what do you think? And I encourage you to think outside the box. Look at a particular problem and try to figure out different ways to solve it. Another thing to note is that this discussion assumes that you are somewhat familiar with the Godot user interface and that you know what nodes are. That being said, I will briefly explain the nodes that I'll be using and why I chose to use them. If at any time you want to skip ahead or rewind, please use the timestamps to jump around the video. And remember to have fun. But enough explanation, let's slide and slither into Snake. The game starts paused, and there's a message that invites the player to complete 3 cycles to master the snake. Clicking on the enter button or hitting the enter key unpauses the game and the snake head moves to the right. The player can either use the arrow keys or the W, A, S, and D keys to move the snake around the play area. In the game UI area on the left of the screen, under the messages section, there's a message that tells the player to eat food. The food is represented by the green square that has a growing green square inside it. When the snake head collides with the food, the snake grows by 1 segment, and the shrink food appears on the screen at a random position within the play area. The shrink food is represented by the orange square with the circles in it. The message changes to eat shrink food, and when the player collides with the shrink food, the snake is decreased by 1 segment, back to the original head. Then another shrink food appears at a random position in the play area. At the position where the food was eaten, a green square appears, and the player must navigate around it to collect the shrink food. When the player collects the shrink food, that's it. You have successfully completed the tutorial, and the first cycle is complete. If the player collides with the green square which represents the food waste, it triggers a game over, and the game over screen is displayed. The goal of the game is to complete 3 cycles of growing and shrinking the snake. There are just a couple conditions. First, at the start of each cycle, the number of segments or parts that the snake must collect goes up, and every time the snake collects food, the speed of the snake is increased by a small amount. Let's take a look at the scene tree. The scene tree is made up of a few different nodes. First, there's a node 2D that would be the root of the scene tree and will hold all the other nodes that make up the level. Then there's the canvas node that holds the UI control nodes for the UI. There's a simple sprite 2D node that will hold the background, a GPU particles 2D node that's responsible for the cool particle effects, the falling squares, and an empty node that holds all the sound effects as audio stream player nodes. There's an area 2D node for the snake head that has a collision shape 2D node and an animated sprite 2D node for the player. And lastly, there's another area 2D node with a collision shape for the play area. Now let's run the game and take a closer look at how it works. When the game first starts, there does not seem to be a lot going on, but there's quite a few interesting things happening. First, the game starts off in a pause state, and there's some UI text on the screen and an enter button. Some of the text has a cool rainbow effect and a wave. So before we hit the enter key to start the game, let's break down how this is set up. Let's go to Project Settings and make sure that the Advanced toggle is on. Under Display, Window, I set the window size to 960 on the width and 540 on the height. I also checked the Always on Top checkbox so that the game window will always be on top when the game is running. At the start of the game, two of the panel nodes will be visible. The UI panel to the left that holds the general UI information for things that are happening in the game, like the cycles, the instructions, and the messages, and the other panel node is the Start panel node. If you're wondering why these panels are grayed out, it's because their process modes are set to when paused in the inspector, so that it will be possible to interact with them and their children when the game starts in the pause state. Let's take a closer look at the Start panel because it has most of the building blocks for all the UI screens in the game. There's a panel node, the rich text label node, and the button node. To create the start screen, I first added a panel node and set its anchor preset to the center of the screen. Next, I added a rich text label node and checked the Enable BB Code box in the inspector. BB Code allows us to add cool effects to our text right in the inspector or by using custom code. But that's a whole other video on its own. So for now, I'll just add the wave and center effect for the text. To get the rainbow effect, I used a simple shader from GodotShaders.com. I can't explain how the shader code works because, to be honest, to me that's some next level wizardry, but I can show you how to implement it. First, follow the link in the description to get the code. Simply copy the code and make sure to read the comments. I am using Godot 4.3. So I guess that this comment about pi being implemented as a constant might apply to me. So I will take note of this. Back in Godot with title rich text label selected, we go to the canvas items section in the inspector. And in the materials, we create a new shader. I will save it in the shader folder I made previously and call it Rainbow Grad. Then paste the code in the shader tab, and just as the comment suggested, we get an error. But since we know what to do, we just remove line 6 and there you have it. The shader works perfectly. This shader is really cool because we can also adjust settings like the intensity, speed, and angle of the effect. Then we add a button node as a child of the panel. And that's pretty much it for the start screen. We will use this same setup for the game over and win game scenes. The game UI panel is the same as the start screen, except we want its process mode to be set to always. That way it works whether the game is paused or not. I used label nodes here to represent the text that will not have any effects on them, like the cycles text, the snake parts text, controls, and grow and shrink messages. Now that we have the UI taken care of, let's continue down the tree. For the background, I used a sprite 2D node and added a background texture that's the same size as the game window. I got this really cool color palette from lowspec.com. It's called Moonlight GB, created by Tofu. It really looks amazing in the examples provided, but I was really struggling with the art, so I reached out to a friend of mine for some advice. But as you can see by the snakehead I drew in Critter, I'm really not that artistic. Anyway, all the sprites that I used will be in the project files on my itch page. Please feel free to play my game or download the project to check it out. Leave a comment if you have any feedback to share. I would really appreciate it. The link will be in the description. Then I added a GPU particles 2D node and made a really simple particle effects of green squares falling so that the background would not be too boring. Now, GPU particles are a whole other thing as well, and I could make an entire video about that alone, but I don't want this video to go on forever. So I just added these screenshots of some of the settings I used. I used an empty node to hold the audio stream player nodes that I will use for the sound in the game, like the spawn sound, the death sound, shrink sound, level music, and endgame music. Which brings us to the meat and potatoes of the game, the player, in this case the snakehead area and the play area. I decided to use an area 2D node and collision shape 2D nodes for this because no physics is being used in the game. The movement will be handled manually in code. The player also has an animated sprite 2D node called snakehead, which I will use to make a simple animation for the player using two sprites and set the animation to automatically play and loop. For the play area, I also used an area 2D node and checked if the player exits the play area and called the game over function to end the game. And speaking of functions, let's add a script to the snakehead and start coding. Line 1. It sure took us a while, but we're finally here. This script extends area 2D. The ready function happens when the game starts, so I will use this to set up some things. As I mentioned before, the game starts paused, so we will use getTree.pause to pause the game. Then I show the start panel and the grow message by calling the show function, which is a built-in function in Godot that toggles the visibility of the node on in the scene tree. The % symbol means that they are accessed in code by their unique name. I also set up onReady variables for all the UI in the game. So if in the video I refer to the start panel, just keep in mind that I'm referring to the start panel in the scene tree. Similarly, for the grow message, I'm referring to the grow message in the UI panel. Then I need to update the snake parts text that shows the total number of parts the snake must have, that is, food to be eaten, before the shrink food will be spawned in the game. I will need to call two functions, initialize positions and set snake start position, which we will look at next. To initialize the positions that the spawn food and shrink food will spawn into the game, I will need an array of available positions and exported variables for the position of the spawn zone and the size of the spawn zone. During playtesting, I found these values to be the best for my game. I have also set an exported variable called grid size, which I have set to 32 because the size of the player is 32 by 32 pixels. I set the spawn zone size to 448 because 448 is equally divisible by 32. I'm not entirely sure if this is necessary, but I did this as a precaution to align the food and the snake on the grid. I used nested loops to traverse the grid. The outer loop I runs across the width of the spawn zone, and the inner loop J runs across the height. Inside these loops, we calculate the exact position for each grid cell. I multiplied by grid size and J multiplied by grid size determines the positions within the grid. Adding spawn zone position.x and spawn zone position.y offsets these positions to align them with the desired spawn zone in the game world. Then I create a vector 2 with these coordinates and add it to our available positions array using .append. This builds a comprehensive list of all possible spawn positions. Finally, to ensure that items spawn in at varied locations each time, we shuffle the list by using the .shuffle function. This will make the spawning unpredictable. Now that we have the array of positions, I'll set the snake start position with a function called setSnakeStartPosition. Remember, in the initializePosition function, we shuffle the positions in the grid? Now we need to make sure that the snake actually starts in the correct spot. I will choose the center of the grid. We start by ensuring that our available positions array isn't empty, so that we have predefined positions to work with before attempting to set the player's position. From the initializePosition function earlier, I can determine start position as the middle index of our available positions list before shuffling. I'll calculate the actual center of the grid in world coordinates by dividing the total spawn zone width and height by the grid size. This gives us the total number of cells in each direction. Next, calculate the exact center of the grid. I take half the total grid width and height, then multiply them by grid size to convert from cell index to actual pixel position. And finally, offset this position using spawnZone.position, which accounts for where the grid is actually placed in the world. Now, the key part. I set the position equal to the exact center of the grid using center X and center Y coordinates. The self keyword is not really needed, but I'm using it to make it clear that I'm setting the position of this node to be the start position of the snake. With all that out of the way, let's start playing. We connect an unpressed signal from the start button to the script, and in here we unpause the game by setting paused to false. And then we hide the start panel by calling the built-in hide function on the start panel. Then we call the spawn food function. I could also hit the enter key to start the game, and that's because I set up an input event called start, which uses the enter key for input. With the start button selected, in the inspector, I set up a shortcut to the new start event, which will just call whatever happens when the button is clicked. In this case, it's starting the game. Similarly, I connected signals to the script for the restart button, which restarts the game, and the end restart button that restarts the game when the player completes the game. All these buttons do is reloads the current scene to restart the game. And I also set up shortcuts for these buttons to work with the enter key as well. Now I guess we should slide over to player movement. The input event function is a built-in Godot callback function that captures all input events. In this case, I'm interested in detecting when the player presses the arrow keys or W, A, S, and D keys to change the snake's direction. First, I need to set up the input in the project settings input map. Inside the input event function, we check if a specific action is pressed using event.isActionPressed and pass in the action's name. These actions, right, left, up, and down, that I predefined in the input map of the project settings, each corresponds to the respective arrow keys and W, A, S, and D keys. To maintain the classic snake game mechanics and prevent the snake from reversing onto itself, we include a condition that checks the current direction. For example, if the right action is pressed and the direction is not equal to vector2.left, direction will be equal to vector2.right. Now in this case, the player is facing to the right, so we can use vector2.right to move to the right and similarly use vector2.left to move to the left, vector2.up to move upward, and vector2.down to move down. To handle the snake's movement in our game, we need input, some variables, and a moveSnake function that we will call in the process delta function. First, the variables. Snakehead is a reference to the snakehead's sprite, allowing us to control its appearance and animations. Speed defines the interval in seconds between each movement of the snake, so a lower value means the snake moves faster. Grid size specifies the size of each grid cell. The snake moves one grid cell per steps, ensuring it aligns perfectly with the grid. Speed increase is the amount by which the snake's speed increases each time it eats food. Direction is a vector2 indicating the current movement direction of the snake. In this case, it starts moving to the right. Body segments is an array that holds the references to the snake's body parts, allowing us to manage their positions and growth. And move timer a timer that tracks the elapsed time to determine when the snake should move next. In the physics process delta function, which is called 60 times per second, we count the elapsed time to keep track of how much time has passed using plus equal delta. And if the move time exceeds the defined speed variable, we set the timer. And then it's time to move the snake. We call the moveSnake function, which is responsible for updating the snake's position. Depending on the current direction, I can also adjust the rotation degrees of the snake to ensure it faces the correct way. Since the player starts off facing the right, I can set the rotation degrees to 0 in this direction, and I will also set the snakehead.flipv value to false. For the left movement, I would set the rotation degrees to 180. I will also set the snakehead.flipv value to true to flip the sprite vertically, ensuring it appears correctly. And for up and down, I will set the rotation degrees to -90 for up and 90 for down. For movement, I will calculate the new position by adding the current direction scaled by grid size to the current position. To update the body segments in the body segments array, we iterate through the body segments array in reverse order using a for loop, setting each segment's position to the position of the segment ahead of it. This creates the effect of the body following the head. And after updating the body segments, we set the head's position to the new position, completing the movement. Now let's look at spawning in the items. We have the food, which belongs to the food group, the shrink food, which belongs to the shrink food group, the food eaten, which belongs to, you guessed it, the obstacle group, and the body part, which I did not assign a group to. So just to review, in the original snake, when the snake head collided with the food, the snake got bigger by one segment, and another food would spawn in the game at a random position. In my game, we need to consider spawning in a food at the start of the game, and when the snake collides with it, spawn in another food at a random position. We already calculated that in the initialize position function. Then, increase the snake by one body part, spawn in another food, and increase the speed of the snake, and after a short time, spawn in the food waste. When the snake has a certain number of parts, I need to start spawning in shrink food, which when the snake collides with, I will remove one body part and spawn in another shrink food at a random position. When the snake body parts gets down to 0, we need to complete one cycle and increase the number of body parts and start spawning in food to repeat the cycle. And after a certain number of cycles, trigger a win game function. Now if all that seems confusing and a lot to deal with, remember, the key to game dev is taking a big idea and breaking it down into its smallest parts and working out one small part at a time. There are many ways to spawn in scenes in the game, but I chose to use packed scenes to do this as exported variables so that they would be easy to change as I iterated the art in the game. I mean, this is what the game looked like when I made it for the Microjam 033 Void. Now that we have the packed scenes, we need some variables and some exported variables. Can spawn food. When set to true, the game can spawn regular food that the snake consumes to grow. Can spawn shrink food. When true, the game can spawn shrink food that when eaten reduces the snake's length. Cycles done tracks the number of game cycles or iterations that have been completed. Endgame cycles defines the number of cycles after which the game will end. Food threshold represents the initial number of food to be spawned. Food threshold increase determines how much the food threshold increases after each food spawn. Shrink food threshold sets the number of shrink food, and waste food timer specifies the duration in seconds the waste food waits before it's spawned in the game. Since I will need to spawn in multiple items, I decided to use one spawn item function that could be called to spawn in the various items. The spawn item function will take a couple of parameters: scene, a packed scene representing the item to be spawned, food or shrink food, and can spawn, a boolean indicating whether spawning is permitted. The function first verifies that spawning is allowed, can spawn is true, and that there are available positions in the available positions array. If both of those conditions are met, it creates an instance of the specified scene. It assigns a position to the new instance by first removing the first entry from the available positions, ensuring there's no overlap with existing items. The new item is added to the current scene by using addChild call deferred item instance. This defers the addition to ensure that it's done safely. Spawn food attempts to spawn a food if can spawn food is true. It also handles the other tasks like showing the grow message and hiding the shrink message and playing the spawn sound, while spawn shrink food attempts to spawn a shrink food if can spawn shrink food is true, and handles the other tasks like showing the shrink message and hiding the grow message and playing the shrink sound. To add body parts to the snake, I will use the spawn body segments function, which creates a new instance of the body scene and stores it in a variable body instance. Sets the new segment's position to where the snake head was previously, ensuring the segments appears to follow the head, and adds the new segment to the current scene using addChild call deferred body instance, deferring the addition for safety. Body segments .append appends the new segment to the body segments array to keep track of all segments, allowing the movement of the body segments that follow the snake's head. Now that we can grow the snake, let's take a look at shrinking the snake, and this is going to be really straightforward. Before attempting to remove a segment, I first ensure that the snake has body segments to remove. This check prevents potential errors that can arise from trying to remove a segment from an empty array. Popback is a method that removes and returns the last element of an array. In this context, it removes the last body segment from the body segments array and assigns it to the variable segment to remove. After removing the segment from the array, we need to remove it from the scene to ensure it no longer appears in the game. QFree schedules the node for deletion at the end of the current frame, ensuring it's safely removed without disrupting the current process. I connected an on-area entered signal from the snake head to the script. This function is extremely important as it dictates the game's response when the snake head interacts with various objects in the game world. It's invoked whenever another Area 2D enters the snake head area, allowing the game to respond to collisions or overlap with different objects. The function uses conditional checks to determine the group or name of the area that the snake head has entered or overlapped, and executes the corresponding logic. If the collided area belongs to the food group, it adds 1 to the snake length counter, adds a new segment to the snake's body, calls the update food spawn logic, which we will look at later, pauses execution of the code for a duration defined by waste food timer, creates an instance of the food waste scene, positions the instance at the location where the food was consumed, adds the instance to the scene tree after the current frame to ensure safe addition to the scene's update cycle, and removes the consumed food from the scene. If the collided area belongs to the shrink food group, then it removes the shrink food from the scene, calls the function to reduce the snake's length by 1 by removing the last segment, subtracts 1 from the snake's length counter, and calls the update food spawn logic function. If the collided area belongs to the obstacle group, or if the name of the collided area is body segment, indicating the snake has run into itself, the game over function is called. On a side note, remember the play area 2D I made? I also connected an on-area exited signal to the script and called the game over function if the snake head exited the play area. And I definitely saved the best for last. I think I had the most fun figuring out this logic. This function plays a crucial role in managing the game's progression by updating the user interface, adjusting the snake's speed, and determining the spawning conditions for the food items. First, I update the on-screen text to display the current number of snake parts, reflecting the food threshold value, and similarly update the display to show the number of cycles completed, based on the cycles done variable. Then the snake movement speed is increased by reducing the speed variable by the speed increase amount. The can spawn food condition allows food to spawn if the snake's length, snake paths, is less than or equal to the food threshold and the shrink food is not currently spawnable. Conversely, the can spawn shrink food condition permits shrink food to spawn if the snake's length meets or exceeds the shrink food threshold and regular food is not set to spawn. Then, if the conditions for spawning regular food are met, the spawn food function is called, and if the conditions favor spawning shrink food instead, the spawn shrink food function is called. If the snake has no paths left, 1 is added to the cycle counter, indicating the completion of a game cycle. Increase the food threshold by the food threshold increase amount, allow spawning of regular food to enable the snake to grow again, spawn the regular food item, check if the number of completed cycles matches the game end cycles, and if it does, end the game. And we did it. As we display the end screen in the game, so too we've come to the end of another video. If you want to play the game or check out the project files, it's on my itch page. I will leave a link to it in the description. It's totally free and I think it's a great place to start. Thanks for watching. We discussed a lot today. Core mechanics with no gimmicks. I do hope this video was helpful. If you liked the video, give it a like and as always subscribe and turn on notifications so you'll know when I upload another video. And speaking of my other videos, there's another great video here where I made a Flappy Bird clone with a special twist. And I also made the project files available for download. This has been Diragu Games.